joined us, and welcome to my day one of live streaming in Capture the Flag, where we'll be doing, let me call it live hacking, but now inside labs with Cybersecurity Academy. As you can see, I'm already in my account in Cybersecurity Academy. So all you need to do is go to your search bar, type in Cybersecurity Academy and follow up with me, create an account and start capturing the flags. So for our day one as a starter, I want to make this easier from beginner level to advanced. So this means we'll be going through the easy labs first, and then as we continue, we're going to be advancing up to the hard labs. So here today, I'm going to start with obedient cat. This is just a simple lab in cybersecurity, just to teach you the general skills and how to navigate inside your Linux terminal. So let's go on and let's search in obedient cat. Here it is. So we have obedient cat and the general skills. Yes, you need them for your Linux navigation inside the terminal. So it says this file has a flag in a plain sight, aka in the clear. So we have this link here to where the flag is, and let's check out the hits. You have any hits about entering a command into the terminal, such as the next one. We'll start with a $sign. Okay, everything after the $sign will be typed or copy and pasted into your terminal. Interesting. So to get the file accessible in your shell, enter the following in the terminal prompt: $wiget and link to the flag. The link can be copied from the details section. So technically this is just downloading the flag directly into your terminal through your terminal, Linux terminal. And let's see the last hint. Ooh, it says man cat. Interesting, because I've never seen such a command on Linux though. Man cat. Anyway, let's find out. So at first you want to copy this. So copy link address and open up your terminal. Okay, so here we are. And remember, you don't want to mix all your stuff and your capture the flag items together, because this is going to get your work a bit disorganized and hard to find some things. So what we're going to do is, let's maximize on this. So what we're going to be doing is first create our new directory where we're going to be doing our capture the flag sessions daily. And remember, this will be happening daily all the way from 11 to up to, I guess, 2 a.m. or a period of 4 hours daily. So here we go, make dir, and let's say scilabs, hit enter. Now we're going to cd into scilabs, hit enter on that. So now remember the link that we copied from our description on cybersecurity. So remember we say wiget, then paste it over here. So hit enter on it. So there we have the flag downloaded directly into our terminal, and you take a look here, we have flag. So this is how it has been saved as flag. So go ahead and ls and see. So we have flag in here. If we cut it, let's see, cut flag, hit enter, yes. And there we go, we've captured our first flag. And what do we actually get to learn from this is that we get to know how it's easier to download items from the browser using our terminal, using widget, and it's easier to read files from your terminal as well, because we've learned how to use cat command, how to create directories from our terminal, and how to change the directory that we are in to the directory that we need using the cd command. So by ls, ls means list. So we're listing everything that is inside our current directory. And cutting it, we got the flag over here. So we're going to copy this. Let's see if it actually works. Yes, and let's move into cybersecurity and here. So let's paste it in here. There we go. We see here we have correct flag found. So with this correct flag, now the next thing that I want us to do is, after learning all about this and how to cut commands, the next lab that we're going to be tackling is Python wrangling. So let's go ahead and search it out. Let's pass on that. Let's do web a flag. So here we go. Okay. So the first step in every lab that you're going to be doing, make sure you read the description, and if there are hints, make sure you go through the hints, because they also help you in finding the flag. So here we see, can you invoke help flags for a tool of binary? This program has extraordinarily helpful information. So we have this link here. Remember, copy it, copy the link address, and then let's go into reading. So this program will only work in the web shell or another Linux computer. Well, that doesn't affect us at all, because we already have Linux terminal running. And the next thing, to get the file accessible into your shell, yeah, the same command that we used, we get over here, and then press the URL, yes, and run the program by entering into the terminal /worm, but you'll first have to make it executable with this command. Remember, these hints help us run, or rather capture the flags most of the times. So here we see we have change mode plus X. This technically means you're going to make this file that we're going to be downloading executable on our terminal, so that we'll be able to run it as a simple and simpler command on the terminal. Next, here we have the -h help or help here are the most common arguments to give to programs to get more information about them. So here we say not every program implements help features like -help and --. So I think they're trying to confuse us in a way, because on hint 4 we see you have -h and help are the most common arguments to give to programs to get more information from them. And then here on the fifth hint we get not every program implements help features like the -help and the --help. So meaning we have to figure this out differently. So we copied this. Let's go ahead into our terminal. There we are. issues. So let's clear on this. Sorry, clear. Then we get again copy, paste, and hit enter on it. So here we have the file ls. Well, I'm still wondering, what's inside this file. Let's cut it and see. Well, it's a lot of gibberish that I can't understand though. So yeah, clear. So let's make the file executable using the command change mode plus x warm. Enter on it and ls. So you see there's a color change from white to green. So now we'll do the /warm. Let's see what happens. Hit enter. Here we're getting hello user, pass me a tag h to learn what I can do. So again, let's do it again. So /warm tag h. Let's see what happens. Yeah, so oh hell, I actually don't do much, but I do have this flag here. So that's how we captured our second flag, and this actually shows us how to use commands that we don't know about. So this technically means if I don't know how to use a command, I'm going to pass the tag h or the tag help to a command so that I get to know exactly what I'm supposed to be doing with this specific command. So let's copy this. Copy, Ctrl+Shift+C. Head back to our cybersecurity labs. And now paste it here and submit it. Let's see what happens. Yeah, so we still get the correct flag submitted again. Next, for our third flag, we'll be doing a nice netcut. Let's need. Oh, I think I found it. So here we are. So this is quite interesting. Still under the general skills. And it's easy. Remember, we're starting from the easy to the hard one. So this means we're going from beginner to advanced mode. So here we have, there's a nice program that you can talk to by using this command in a shell. Okay, let's check out the hint first. You can practice using netcut with this picogym problem. What's a netcut? Okay. You can practice reading and writing SCII with the picogym problem. Let's warm up. Let's launch the instance and see. So here we see netcut Willy Courier. Okay, let's copy this. So we're going to be running on our Linux terminal. So technically you are connecting to Celeb Security Academy using netcut via our terminal. So we're going to copy this. Yeah, and move back into our terminal again. So here we are going to paste the command. So nc netcut and then our URL, and then this is the port number that we're connecting to. So hit enter on it. Interesting, as we see we have a couple of digits, values, but remember we need to like read this in SCII. So this challenge shows us about network communication. So at first, we have raw network sockets where we are interacting with a raw TCP socket, like literally from this network connection, we are literally interacting with a raw TCP socket, unlike standard web traffic, HTTP, which includes complex headers, and raw TCP connection simply opens a pipe and dumps data. So what is here is data serialization. Computers only understand numbers. So when applications send data over the network, text is broken down into bytes. You get so text get broken down into bytes, and the application format the bytes, and then I think it's yeah, the application didn't like format the bytes back into characters before sending. So this is forcing us to handle this challenge by decoding the logic, where we're now going to, like, instead of us viewing this first, we're going to pipe this into a decoding script or command. We're going to still copy it. Yeah, so we're going to pipe using this. So this actually means piping. So we are piping this into a different set of commands. So we'll do the awk. So what this does, this is a powerful text processing language built into Linux that reads input line by line. And then we have then print. No, actually here we have opening curly bracket and then print. So we're actually going to turn this into SCII. So remember I told you to read the hints. So from the hints here we get where is it? Here. Remember here, so this one tells us you can practice reading and writing SCII with the Picogym problem. And remember here I still said you can practice using netcat with the Picogym problem. What's netcat? So technically this tells us we need to, instead of connecting directly into this, first connect to it, then send it to another set of instructions so that we can get the SCII. So this is like the readable format, human readable format. Yes, so that's it. So let's go back into our terminal. So printf here and then the quotation marks, and we'll use the $C, close, then close this up, and this up we actually need some here comma, and then $1, make a bit of space over here. Let's see what happens when we hit this. Okay, I think we're getting an issue on this. I think, yeah, so the issue over here, so delete on this, and over here, place it here, so let's hit enter again. Yeah, there we go. We found our next plug, which is good kitty, nice kitty. So copy this and let's see if this actually works. So yeah, this is it. And the printf, it's a formatting function used to print data in a specific style. unlike print, it does not automatically add a new line character after running, so which keeps the text grouped together. And the was this the percentage and then C, this is the magic formatting tool. So this tells the system, take the incoming number, treat it as an ACII code, and print its matching keyboard character. Are you getting it? Yeah. And the last $1 represents the first item or column of the current line. So since the network output only sends one number per line, the $1 matches that exact number. So let's paste this into our Scilab and see if it actually works. Yes, it actually worked, and we still got the correct flag again. So this is actually leading us to getting to know how to use our Linux terminal and how to navigate through it, and it's making work easier rather than combining other tools. We can only use our Linux terminal and do everything from it. So the next lab on this live stream, we're doing, I guess, the warmed up. So here, the search, we do again warmed. So, well, actually, I think it's actually good because we're going from warmed up and then to warm, and then yeah. So let's do warmed up. This is actually interesting. So it's a bit of hexadecimal and decimal. So the hexadecimal here is the base 16, and the decimal, generally the normal characters, 1, 2, 3, 4. But in cybersecurity or programming, it's not normal numbers. So we have the decimal base 10. This is the normal number that we see. And the base 16 is the hexadecimal version of a number. So let's see a hint. Submit your answer in a flag format. For example, if your answer was 22, we would submit precocity of 22 as the flag. Now here we have what is 0x3d base 16 in decimal base 10. What is the base? Actually, what is base 16 in? So what is the decimal format of this value here? So this leads us to another. It takes us to another way of viewing figures on our terminal. So we are only required to convert this into base 10 from base 16, and this can be easily achieved, I think, using a Python script or online tool. You can use CyberChef, by the way. We have cyberchef.io online. I'll show you how to use it, and I'll also show you how to use this on your terminal. And it includes a bit of Python in it. So let's move into our terminal let's first check out cybership.io. Here we go. So this is cyberchef. So let's over here copy this out. and then move into cybersecurity. So here we have the input. Put this in here, and then let's check from hex. You're supposed to put the common search over here, decimal. Yeah, so let's take this back and then press this decimal. Interesting, yeah? Okay, so 3D, 0x3D in hexadecimal. Well, let's do this. Wait a minute. So I think okay, let's first check our terminal. So clear on this. Yeah, so we'll first go into typing Python because we're going to be using Python to decode this script. To decode it, Python 3, and we're going to be using the tag C, so we are pushing it directly, so we're only using a single line, a single command, no need to like create a whole script and then run it separately. So we're using the tag C to make it into a single line command, and then quotation marks. So use the print. So print the integer format of the integer format display, then integer, then another bracket again. So we still have to add its own bracket, and then now in here is where we type our values. You have the 3D, the last value. So 3D after the yeah, and they still need a single quotation mark. So 3D, then comma. So we are turning this from base 16 to less 16. Yeah, I think, and that's it. So this will decode from base 16, which is the hexadecimal, into base 10, which is a decimal. So hit enter on it, we have 61. When we go back into CyberShare, so remember we got the format that's supposed to be submitting this. So copy on this. Yeah, let's head back into CyberShare. Here, so let's do the Pico CTF. Yeah, the curly bracket, and then paste our answer in there, then submit it. Let's see, you still got the correct plug. So that's how we decode from hexadecimal to decimal. And using CyberShare over here, remember we had the 3D. 3D to decimal will actually not. Let's reload this first. 3D, so push comes from hex decimal. Yeah, and that's how we do it, from hexadecimal and then into decimal. We still got the same answer, 61. That's how it is. So next is tool. Let's click on it and see what's actually with it. Because remember, read the description, the hints, and then move into solving. So here we have, can you convert the number 42 base 10 to binary base 2. So submit your answer in a competition flag format. For example, if your answer is 111, you would submit Pico CTF. Yeah, we're now converting from decimal into binary. So the number 42 is a decimal. We have 42 base 10. That's a decimal. And so the best way to do this is convert using a Python script that will take in input integers in base 10 and convert into base 2 by dividing it by 2, and the remainder is stored for the binary base 2 answer, which will always be 0 or 1. Yeah, because that's how we identify values in binary: 0 or 1, 0 or 0 and 1. And the divided value is pushed to the next step in a loop until the division is complete. So I have this script that I came up with that I'm going to be using, but let's see if we can actually do this on CyberShip as well. So let's move here, then click on this. Let's type in 42. Okay, so let's take this back. So we are moving from decimal into binary. So let's see, from decimal binary. This is so that was actually easy. I mean, so let's copy on this. Let's see if it actually works, by the way. So copy and write in here again, little Pico CTF. Submit. Oh, that didn't work. That's incorrect. So we'll move on to my script. So here I'm going to copy. Let me show it to you. So let's move into terminal. Again, still a Python script. So let's click on this. So let's say nano. So this is the text editor in your terminal. So nano, let's call it decrypt.py. Enter on it and then paste it. So here we have. So we're going to ask for a base 10 number and turn it into an integer. So the number is number equals to input, number integer input. So enter the base 10. So this is prompting the user to input the number that they need to be. You get what I'm saying? Yeah, the number that needs to be converted into binary. And this is the function. So if the number is 0, binary, the binary result will be 0. And else the binary result is not 0 here now. So we have a loop that's going to go on until we get 0 and on the last digit that remains. So while the number is greater than 0, the remainder is still get the remainder. So if we get a remainder, so 0 or 1, yeah, so the binary result string remainder plus the binary, so it's going to be passed on until we get a 0 in the complete division of it by 2. And then we're going to print the binary representation, binary result here. So let's save this. Control C, Control X, Control. And then yes. So now we have to run the script. So Python 3, and then decrypt by hit enter on it. So we have to enter our base 10 number, which is 42. Hit enter on it, and then we have our binary as 100. Let's copy it. Image here. Hey, do you notice something off? Wait, before pasting, let's try and eliminate this one. Yeah, so apparently we still got the correct answer, but anyway, so this space limit, okay, yeah. Also, this was in 8 bits, so technically we still have the correct answer, because this one we have the last two zeros over here. Fill this up from 6-bit to 8-bit format. So if we change this to, let's say, 6-bit, we get the correct answer. But yeah, so cyberchef.io still works, and there's no need to taking your time cramming the script. You can simply use cyberchef.io, but just know how to use it and you'll be safe. So yeah, that's another flag we got, and that's how capture the flag labs are as easy as that. So yeah, that's two. Yeah, and let's move on to our next flag. I guess let's see. Our next flag would be strings it. I think this is actually giving me strings. We have to learn how to use strings on our terminal. Yeah. String. Wait. Oh. Yeah, so here we are, string it. As usual, first we have to read. Can you find the flag in file without running it? String. Does this ring a bell? Because I think we're supposed to use strings and cut the flag from this file without checking it, without checking what exactly into this file. So we'll know what to do. Copy the file, the link address, and then move into our terminal. Yeah, so here we are, and clear on this. Yeah, so we'll know what to do. Widget. Yeah, there we go. Enter on it, and this is the file. Yeah, so there we go. We have strings. This is the file. Let's see. Yeah, strings. Here it is. Strings. So remember, we have to run this without. We have to find the flag without running the file. So let's check what's inside it without running it. So let's do a cut string. Yeah, I know that would happen. Yeah. So there's a lot of gibberish here. So technically you have to filter for the flag using the strings command. So what we're going to do, so since we've already seen what's actually in the file, but we didn't run the file. So let's do string, and then select our file, strings again. So, and then now we are going to pipe this command into a grep command again, so that it helps us identify the specific values that we need for our flag. So let's pipe our command into grep -i exclamation marks, and then Pico, our flag format, CTF. You can leave it as that, but I prefer this way because it's easier to spot. So hit enter N. That's how we found our flag. So copy on it, then move into our Cybersecurity Academy and paste it and see if we actually got the right flag. Yeah, we got correct flag found. So, and that's how we use strings, because there's no need to like go through the whole file, and it's going to be tiresome actually, because reading through such kind of data is hard. So we use strings and grep to filter out for the important details that we need. Next, we'll learn about grep next. So we move into our next lab, that is first grep. Yeah, first grep. Still under the general skills, and our description says, can you find the flag in the file? So this would be really tedious to look through manually. Remember, so grep still another command that still works the same way as find, and so something tells me there's a better way. Yeah, of course, I mean, from the title we get first grep. So this tells us in this lab we're going to be using grep to find the command. So yeah, so grep to we're using grep to find our flag. So copy the link address as usual. Move into a terminal. Let's clear screen. And we get this. So ls. So here, so let's see, cut flag, no, file. Here we still have the same issue. So what we'll do actually is we'll do grep file we'll still use strings. Let's see if strings actually work. Strings file, then pipe it into grep. This is the same because it here. Yeah, that didn't actually help quite much. So let's see what this gives us. Pico. Yeah. So if you look quite good on this, we have our flag right here. Yeah. Grep is good to find things, and this is our flag. So let's copy it. The selection. Yeah, move back to our cybersecurity lab. And paste it in here. And let's submit. Yeah, we still got the correct flag, so still the same way. We learned how to use strings and grep. So this is how capture the flag keeps getting interesting. Well, I can't wait for us to get to like the let's say the advanced mode. Yeah, the advanced section, because this is just the beginning. So you see, we only going through the general skills and everything that we need to navigate inside our Linux terminal in our Linux machine, making which will make it easier to navigate in the advanced mode. So let's move into bases now. Let me see. Okay. Here we go. So what does this mean? I think it has something to do with bases. So submit your answer in a flag format. You would submit Pico as the flag. So let's take a look at this. Because this looks more like a base 64 encoded character over here. So if we copy on this, let's see, copy this, then move into a terminal. Let's clear our screen and paste this over here. So this one this one looks like a base 64 encoded character. Well, don't ask me how, because if you look at the values in here, it's a mixture of caps characters ranging from A to Z and values from 0 to 9. I mean 1 to 9. So let's pass this into, so let's do an echo, then V, pipe it so that you can decode it into from base 64, then dash D, meaning decode, hit enter. And here we are, learn the ropes. So this is our flag. After the flag again, copy it. Move to a cybersecurity. We don't remember, you have to like submit it in the same format. This is Pico CTF. Hit enter, let's see. Here, correct log file. And we have base 64, we have base 32, and all the other bases. So it's you actually have to understand how this works, because in this challenge we are provided with a word that is encoded in base 64. So we are required to decode it and submit it as a flag, and using the flag format though. So the base, so since we piped it into a base 64 decoding command, it gave us the exact word that we needed. So now we move into our next lab, that is the static ain't always noise. So let's first check it out. Remember to read the description. Static, so static ain't always noise. So it tells us, can you look the data in this binary? The bash script might help. Okay, so let's copy the link address. Okay, we still need this, so let's first move into a terminal. Let's clear our screen. Let's do the widget. Paste the static over there. We have it here, so let's cut it. Let's see what's in it. Static. gibberish as well. So yeah, remember it told us that the SH can help us understand this. So can you look at the binary? So the bash script might help. So this is the bash script that we need. So still copy the link address, move into a terminal, and we get again, paste the link address, enter, and ls. So here's the bash script. So in bash we use bas and then lt. Let's see. Attempting disassembly of okay, text mentioned, AJ option, but not found in the input file. Usage. Oh, so here we have how to use this bash file. So we have usage ltdis.sh, then the program file follows up next. So let's do it. Then static, hit enter on it. Attempting disassembly. Any strings found in static have been written to static ltdis with file offset. So let's say lesson 2. So here's the new file that has been written with string. Let's copy it, Ctrl Shift C. Yeah, let's cut. Let's see what's in it first. So we have a lot of strings actually. So, and we found the flag right here. You see? So, but take it as you have a long list of values like this, and you don't know where to start from. What do? You do the strings, and then our file name. So we paste it already. Then pipe it into grep double quotation, and then equal CTF, hit enter, and gives us the flag immediately without having to go through the entire file. So copy it, then move into the Cybersecurity Academy and paste it there and submit it. Yeah, and we have correct flag submitted. So if you take a close look at this, we see that every command that we've learned how to use from the beginning, we keep on using them as we keep on moving. So this tells you that every command is important in Linux, meaning without certain commands, it will be hard for you to navigate inside your Linux terminal. So it's quite recommended you learn the basics first, and how to create directories, move across directories, move back to your previous directory in Linux, so that it becomes easy to use when doing some of these labs. And what we're going on to is tab attack. So this lab, let's have a look at it. So it's saying using tab complete in the terminal will add years to your life, especially when dealing with long rambling directory structures and file names. Let's check this out. So after unzipping, this problem can be solved with 11 button presses, mostly tab. Okay, so let's have a look at it. So let's copy the link address as usual and move into a terminal. And then let's clear this off. So let's do the widget using command and paste this over here and do this. So remember, in this lab, we're required to find a flag that is located deep in a file. So if we ls files to the end of the directory at once, we'll actually get to find our flag easily. Let's see. So let's unzip. So use the command unzip and this is the file. Paste it, enter, unlock. So let's go on ls. So we have a new directory here, so that we need to, let's take a look at it. cd v. Okay, let's see. So take a look at this. So actually, what's actually happening here is that we have a directory inside a directory inside a directory inside a directory. So technically, if I have to do this manually, it's going to take me like such a very long time to complete. Meaning, and it's going to be sometimes I don't know how many directories I have to move in. So let's move back into our previous directory using the command cd. Okay, no, okay, yeah, we're actually good here. So what we're going to do is we'll do sudo. We'll actually go into this directory here. Then do the sudo. So we're going to ls at once, so that we get to the end of the directory at once with just one command. So yeah, that's the ls, but ls won't work alone on its own. So we have to add the tag r e. Let's see, put your password here, and there. So we have our last directory here, and we then move forward to cut the files and find the flag had coded inside a code. So if we take a look at these files over here, this looks quite interesting because it's C. It's code written in C. So then let's first check this out. Then cut. Let's have a look at it. Oh, such file directory. Okay, so this is what we do first. We first need to, we are at what? Yeah. So here, first need to move into this directory. Let's copy this, Control Shift C, V. Not possible. Okay. So let's pass clear on this. Let's have a clear look at this. So we'll do, yes, we'll select. So from this directory, we have this directory, and then from this directory, which is this directory, we have this. So let's copy all of this once from here, then paste it, hit enter on it. We have the last directory, so ls. Yeah. So this is the command that, this is the file that we need to check first. Then cut into it, push it through, enter, and here we find our flag. So copy and move back into cybersecurity, paste it. So notice that we've learned how to use ls in a different way and not the usual way of listing the files as usual in just one directory. meaning now we know how to list files from the parent directory all the way to the last directory. So let's move to Scilab security first. Paste this in here, submit, and we got the correct flag again. And this is how interesting keeps on being. So let's move on to our next lab. That's the big zip. And let's see, big zip here. Another unzip. So can grep be instructed to look at every file in a directory and its subdirectories? So copy on this, and the description says, and this archive, unzip this archive and find the flag. Yeah, as usual, we need to go to need to move back into our terminal. So let's click on this, and then cd file, and then move back to Scilab. So we get hit enter on it and unzip. Here we have the file we need. Copy and paste it over here. That's a lot of files that we need to go through. So okay, let's click on this. Okay. Let's check what's inside of it. Copy, so let's. Wow, yeah, that's quite a lot. So in this challenge, we are given a huge folder with a lot of files. Hence, we're required to extract a hidden flag in one of these files. But since there are very many, it will be very tiring to go through one file after the other. So hence we are supposed to use grep. Remember, we've learned how to use grep from our previous lab. So we'll use grep to quickly filter through those files and folders for a unique string. And so to achieve this, we all know the format of our flag. We all know how our flag looks like. So we're going to be using grep, putting it alongside our flag format to find the flag itself. I mean, do you get how this is? So the period is to like, and okay, let me show you how to do it. So let's do grep dash dash y equals CTF as usual, then command then period at the end. So this period over here instructs grep to search through the entire working directory for a file that looks like our flag, and that's why we've passed in the CTF flag format. So let's hit enter on it. Okay, so grep is a directory. Okay, so let's move back and show it again. Grep this is a directory. So to actually do here, let's see what this gives us. I think maybe we should run this inside. Yes. back into the exit files and then to do this command inside here. Let's see, let's give it time and see if this actually works out. Because yeah, not apparently, I mean, it's supposed to work in that format. Because this period is going to tell Grep to move through all these folders and files and find us the flag that we need. And so as we let that finish, so we need to like understand, can grep be instructed? Okay, yes, we already did that. So if this finishes, I think we'll be moving into our last lab of the day. That's binary search. But still need to get this figured out. So we have binary search coming next. And that'll be our first live streaming live hacking. Well, technically, yeah, this is hacking, because how would you get files that you need in a system that you've attacked if you don't understand the basics of Linux and how to instruct the Linux terminal to give you files? So technically, so this will be used in the future when you know what I'm talking about, yeah? You know what I'm saying, but strictly this is for educational purposes. Do not perform these attacks on systems that you do not have permissions, permission to test. Only do this in your isolated lab like cybersecurity labs or your own home network. Yeah, so our next is binary search, which is called binary search. In binary search, actually, it's more like theory. Well, not theory. It's checks on how you can guess. You know, cause in binary search. Okay, let's first check this out. Okay, let's see if it's actually done. Well, it's taking a longer time than usual. You still have the same file. Okay. Pico CTF. So grep Pico. Yeah, we have the same file over here. You know, actually, you know, we're getting directory. Do you have this lot of files? Let's do the CD over here and then delete. Well, that it's quite interesting that didn't work. Yeah, so let's move back into our Excel. Delete play. Well, it's still going to take, but it's recommended we use this dot over here. So it's, yeah, leave that. Let's save that off. So let's move into binary search, I guess. So let's check binary search and bar. We're still coming back to this. So here we have, okay. So it says want to play a game. As you use more of the shell, you might be interested in how they work. So binary search is a classic algorithm used to quickly find an item in a sorted list. And can you find the flag? You have 1,000 possibilities and only 10 guesses. So cybersecurity often has huge amount of data to look through. Yeah, that's correct actually. And from logs, vulnerability reports, and forensics, practicing the fundamentals manually might help you in the future when you have to write your own tools. Yeah, okay, so yeah, this is a challenge that we need. And so have you ever played hot or cold? Binary search is a bit like that. So you have very limited number of guesses, try larger jumps between numbers. Then here, the program will randomly choose a new number each time you reconnect. So this means if you connect to the server and disconnect, so when you move back in, it's going to pick another number that you'll have to guess. So you can always try again, but you should start your binary over from the beginning. Try around 500. Can you think of why? Okay. So this tells us we're supposed to find a hidden number between 1 and 1,000, and we only have 10 guesses or fewer to unlock the flag. So the catch in this, the target number and randomizes every time you start a new connection, meaning you cannot brute force it across multiple connections. So you must use a mathematically optimal search strategy in a single session. So this challenge, binary search, introduces an O log n algorithm used in cybersecurity for rapidly filtering massive log outputs, indexing databases, and parsing network forensic data. So instead of guessing sequentially 1, 2, 3, 4, 5, 6, which is low, you guess the exact middle of your current search range. So the program will tell you if the target number is higher or lower. By doing this, every single guess cuts your remaining possibilities exactly in half. So at start we have 1,000 possibilities, and if we guess by half, our first guess by half, we have 500 possibilities left, and our second guess again, we take another half of the 500 that are left. We'll get 250 possibilities left. So meaning by the time we get to guess 10, we'll have narrowed it down to a single exact number. And because if you take 2 to the rest, 2 power 10, you get 1,024, which easily covers a range of 1,000. Yeah, so that's how we get through it. And let's start the instance and see. We have to connect. So here we're using SSH, so secure shell. So this is the password. Well, we can't copy the password first, so let's do this first. Let's copy this. Move into a terminal. And we'll let this continue, so let's go to our next tab and paste this in here. So SSH secure shell, tag P, this is the port number that we are targeting, and this is the link to our Scilab Security Academy. So we'll hit enter on it and move back into our Scilab and collect the password that we need for this session. Let's see. we need this buffer. So let's go. Let's go in here and move here. So yes, paste it in. Wait, let's move back. Let's check this out. What did we use the wrong? Yeah, so here we are. So we only have 1,000 guesses. So let's start from the middle, 500. Which enter on it. So now it tells us higher. So meaning our value is higher than this. So if we used 500 and didn't get much of it, what if now let's do half of 500? So let's add 250 more on it. So let's do 750. Enter and see. Still tells us higher. So let's add another 125 on it. So that means we're going to 875. And let's see, 875. So now we know where we range actually. So we've only used 3 guesses, and now we are in between 750 and 875. So what's the next move after this? So if we have 875, so let's go for 800. Let's see. Yeah, so it tells us higher. Now we have between 800 and 875. So let's do half of it again. So let's go for 830. Higher needs more. So 835. Still need more. So if we're running out of our guesses. So meaning 835 and 875. What if we try? Okay, let's see if we got 870. Let's see. So it's lower. Okay, so 850 lower. 800 and so if it can't be 835, so meaning it's lower, so it's between 835 and 850. So what comes in between? We'll go for 840. Let's check that out. So still lower, so meaning actually that, so we have 1, 2, 3, 4. So this is actually our last guess. So if we can't get this right, it means we have to try it again, and the number that we have to guess keeps on changing. So that's how you do it. And again, tomorrow, same time, same place, will be moving on to more advanced labs than this. So keep on practicing on cybersecurity labs, yeah, and get your skills better. So let's blow this up. Yeah. 8, 3. Okay. out of our guesses. So yeah, we have to do that again until we get our right flag. Thank you for joining into our today's live session, and yeah, hack, learn, and protect. Ian here, and see you in the next live session with the more difficult and challenging labs than this. So this was actually to get familiar with our Linux terminal and how to actually maneuver inside our terminal easily instead of moving directly into our graphical. And by the way, if you like come to look at it, the terminal is actually easier than the graphical user interface to use. Just tell me in the comment section what you think between the terminal and the graphical user interface. Which one is best to use? Tell me in the comment section, because I personally I think the terminal is better. Yeah, I think the terminal is better off than the graphical user interface, but I don't know about you, so tell me in the comments what you think is better. Is it the terminal user interface, or I mean the command line user interface, or the graphical user interface? See you tomorrow, same time. Subscribe to my YouTube channel and click on the bell, and don't forget to share and comment as well. Tell me what you need more in these live sessions.